Analytics really emphasizes looking at what we are doing or have done to improve what we do in the future. So this segment is about designing work itself and then of course measuring it, which would lead us to more design and so on. What we're talking about here is who's going to do a task, what is that task, how are we going to do it, when is it going to do it, where, and maybe to some extent why, but ultimately that probably is about efficiency and effectiveness because that's what we're after. We've talked about specialization in the past and will probably in the future as well. But when we think about specialists, we think about doctors and lawyers, but it can also go to other laborers. Think about a plumber as opposed to a general handyman. And having specialists offers all sorts of advantages. It simplifies training. Now, maybe not for a surgeon, you're going to be a general doctor, but a surgeon doesn't necessarily need to know about the exotic eye diseases that an ophthalmologist does. But they need to know an awful lot about surgery that the ophthalmologist doesn't need to know about, except on the eyes maybe. But this specialization allows less training than a generalist. And this would apply to other areas. You know, a road crew. When you drive by people fixing the roads, you'll see, a guy directing traffic. That's his job. Somebody else operating a machinery. Somebody else with a shovel. And probably some guy with his arms crossed supervising. But you have specific tasks for specific people. They jump in, do that task. There's not a lot of transitioning between things, hopefully to do it efficiently. In the operations realm, you probably have some guy on the production line who's responsible for bolting on the fender of a car, and somebody else who puts on the brake pedals, and somebody else who mounts the stereos and so on. But by having specialization, they know their tasks, they know how to do it right, they know how to do it with a high level of quality. And that's what we're working with here. Lots of advantages. I said simplifies training. In fact, makes training less. You can do high volume. But there certainly are downsides to it. You have monotonous work, limited opportunities for advancement because you're trained on one little thing, you're good at it, and if they switch you, they got to train you again. You have a little control over your work because you're doing a small task and there's not much creativity allowed in that task. So specialization, clearly good, but maybe bad as well. We kind of have two schools of thought. The efficiency school and the effectiveness school. Efficiency emphasizes a systematic, logical approach to make things faster, smoother, and so on. But the behavioral school thinks about the satisfaction, the happiness, the wants of the employees, because a happy employee is a productive employee. Well, we really need something in between, right? We need tasks that are small enough to keep training costs down and to make highly skilled professionals at small tasks, but we also want them to be happy. So we think about things like job enlargement, which is giving a worker a larger portion of the total task, okay, by allowing them to do similar level skill tasks, but more of them. So maybe not just bolting on the fender, but also bolting on the wheels, as an example. Instead of giving the person more tasks, perhaps they switch tasks. The guy who bolts on the fender swaps with the guy who bolts on the wheels. So they're doing slightly different tasks. And of course, you might even have more rich swaps. But maybe you enrich the job itself. Allow them to think about coordinating the task. So this we call vertical loading because it's not kind of the same skill level, but now they're actually deciding on what is done and how it's done. But you know, a lot of these discussions go to the quality of employment, and there are loads of things that go into this. Frankly, we don't address a lot of these in detail in analytics, but there are certainly some areas that that impact it. I would like to say some things about pay systems, however, because well, pay affects the cost of products, and it does come into play when we're looking at optimal approaches. Now, this hierarchy is kind of the general way we pay people. In most cases, we give some kind of base salary. Then there are benefits on top of that, health care, things like that. And there may be other perks that aren't tightly related to the job, like gym memberships or anything that goes along with the job but really isn't directly related to the jobs. And then finally, bonuses and incentives, things that aren't promised but might be related to the performance of the employees or of the company as a whole. So here are a couple different kinds of compensation system, and you can think about with some of the analytics we've already done how this might play into the model. Time systems, well, we base compensation based on how long you work, you know, punching the time clock, or just working weekly, working 40 hours. This is opposed to output base, where each piece they produce we pay them for. And there could be combinations of these things where you have a base pay and then on top of it that's based on showing up, time-based effectively. But then on top of it, there can be an incentive system for producing over a certain level. So these aren't just one or the others. And when we're computing costs and inputs to products and so on, the choice of these might actually impact performance. But in order to do this, we're going to need to measure the work, either to pay people or to know that we're efficient or effective. And that's really the emphasis of this model, how we're going to measure the work, how we're going to know how long things should take and do take. One approach to doing this is a motion study, where we actually look at the elements of performing a task. Do this in athletics. I show a runner and a golfer here where they videotape them, slow them down, and actually look at how the foot is falling or how the wrist is turning and how that impacts performance. In fact, there's this word called a thurblig, which is an elemental motion, a basic elemental motion of a job. And thurblig, by the way, is simply Frank Gilbreth, the guy that came up with this notion. His last name backward, thurblig, but that's this elemental motion. So we can do a micro-motion study where we break things down. Now, of course, in the production environment, yes, the same sort of analysis can occur. So if we bring back our car, we can look at, you know, what's the right way to bolt that fender on? How should they turn? How should they move the fender onto the car? Should they pick up the bolt before they pick up the device that they bolted on, and so on, right? So you can do the same thing in a production environment. So when we develop the work methods, well, we can use this information to eliminate unnecessary motions. We can think about activities that logically can be combined because they fit well together. On the flip side, we got to worry about worker fatigue or injury by doing repetitive things. This brings up the idea of ergonomics, design of the workplace, so we can have repeated motions but without fatigue or injury. We can improve how things are arranged so that we limit the movements necessary to perform a task, or even create new tools or redesign, modify those tools so that they work perfectly for the task and limit repetitive motion injuries. Okay, so we get these work methods, but before we develop them, and then after we develop them, we're going to need to measure them. And there are different ways to measure how long it should take to do a job. But a caution, this is about how long it should take, not the job content or how the job is to be done. That's all very important in workplace design, but we're going to focus a little bit more on measuring things. And how are we going to measure them? Well, one way we can measure how long it should take is literally time people doing the job. Now, some people are slower, some people are faster, so on top of that, you're going to need an experienced person to decide in looking at them, they're actually doing things a little slower than they should, or a little faster than the average, and so on. So that's the stopwatch time study. Literally sit there and sample times. Another way is to just periodically, at random intervals, see if people are doing the task. If you know what proportion of time they're doing a task, then you can tell how long the task should take in its entirety. Now there are more methods as well. One is we can go back to our old stopwatch time studies or work sampling, look at those records, and based on very similar tasks, we can pull these things we call standard elemental times and put those together and estimate how long a related task might take. And hey, we can go outside our companies. There are literally tables of these micro motions that you can chain together to tell how long your task should take. That's kind of out of industrial engineering and that whole field. So these are the things we're going to look at in this module, particularly the time studies and work sampling.